A very good morning, everyone. In this video, we are going to talk about evolutionary tree. Evolutionary tree is called phylogeny. Phylogeny show paths of evolution and relatedness of species, which makes them helpful because they allow us to understand evolution on a larger scale. This is the anatomy of phylogeny. The root is at the very bottom, and this is where the rest of tree stems from. The root is the common ancestor of all organisms present in the tree. The internal nodes represent other common ancestors present in the tree. Nodes also indicate diversification of species. In this tree, the rabbit and horse both share two common ancestors in addition to the root. The terminal nodes or tips represent current organisms. Although they may not seem related, they show relationships between species that you may not even thought of. A branch is also part of an evolutionary tree. These groups are sister taxa. They come from the same direct common ancestor. The in-group shows the species with common characteristics relevant to the specific tree. The outgroup is a species that is included in the phylogeny but does not fit in well with the tree-specific classification. However, they are all related. Note that the outgroup does not have any branching occurring. This does not mean that the outgroup doesn't undergo any evolutionary change. Branching is just not shown in the outgroup because the outgroup itself does not fit in with the common characteristics of the tree as a whole. In this way, the outgroup acts as a reminder to biologists of the grand scheme of evolution and that species that may not look somewhere it can still be related. Now, we are going to discuss about methods for determining trees. There are three common methods which are maximum parsimony, distance, and also maximum likelihood. In this video, we are only focusing on distance. Distance method is looking at the number of changes between each pair in a group of sequence. The objective of this method is to identify a tree that positions neighbors correctly and that also has branch lengths which reproduce the original data as close as possible. So the distance score is counted as number of mismatched positions in the alignment and also number of sequence positions that must be changed to generate the second sequence.
Now we will try to find the distance or the branch length of this tree by using Fitch and Margoliouth algorithm. So first, we must locate the most closely related sequence from this distance table. And from this, we can see that D and E have the most closely related sequence with 10. Next, we create a new table by combining the remaining sequence like this. And we need to fill in the table. We already know that the distance of D to E is equal to 10. And now we need to find the distance of D to ABC. How to find this? So we can take the average of each of these. So the distance of D to ABC can be calculated by taking the average of 39 plus 41 plus 18 and divided by 3, which will give us 32.7. Okay, next, using the same method, we need to find the distance of E to ABC by taking the average also. So 41 plus 43 plus 20 divided by 3 and we will get 34.7. Put it here. Okay, once we have done with this, we can proceed to the next step. The distance can also be found by averaging the sum of the length of this appropriate branch. So basically, we use algebra to do this. So the first step is we find the distance of D to E, and we have already know the distance of D to E is equal to 10. So D to E is equal to D small d plus small e here. Small d plus small e equal to 10. And this will be our first equation. Next, we find the distance of D to ABC. So the distance of D to ABC is equal to D plus G plus C plus 2F. Why is it 2F? Because F is branched out into 2. Then plus A plus B. And this must be divided by 3 because it has 3 different sequences. So we can to make this equation is look simpler, we can note this equation by substitute it as m. So we will get D plus m equal to, from our calculated one is from our table 32.7. So this will be our equation 2. Okay, proceed to the next step. We will need to find the distance of E to ABC. So distance of E to ABC is noted by E small e plus G plus C plus 2F plus A, and it is the same as our M. So to make it simpler, we just substitute it as M. So E plus M is the distance of E to ABC. So from this table, we can find that the distance of E to ABC is equal to 34.7, and this will be our third equation. So what is the next step? Solve the algebra. So basically, the equation 3 will be minus with equation 2, and hence we will get E plus M minus D plus M is equal to 34.7 minus 32.7 equal to E minus D equal to 2. Okay, this will be our fourth equation. So next, proceed. The fourth equation will be added into our first equation. So D plus E minus D is equal to 2 plus 10. So from here we can get 2E equal to 12, and our E is 6. So using the equation 1, we know that D plus E is equal to 10. So our D is 10 minus 6, which is 4. Okay, now we know the distance of E and D already.
Okay, since we already know that the value of D is 4, E is 6. So now we want to calculate what is the value of C and G. So we have to create a new table that consists of A, B, C, and DE. So this number we can get from the original table, 22, 22, 39, 39, 41, 41. Whereas for 40, we can get from the average of 39 plus 41 divided by 2. So we will get 40. Whereas for 42 is from 41 plus 43 divided by 2. So we get 42. Whereas for 19, we get from the 18 plus 20 divided by 2. So from this table, we can see that 19 is the least mismatch, which is the distance between C and DE. Okay, next step, we will calculate the average of the remaining sequence. So the distance from C to AB is 39 plus 41 divided by 2, which is 40. And the distance from DE to AB is 40 plus 42. 40 plus 42 divided by 2, we will get 41. Okay, so now we create another new table which consists of C, D, E and average of AB. So 19 we get from the list mismatch just now. 440 from here and 41 from here. So next, we proceed to make a new branch that consists of A, B, C and D, E. So here we assume that this distance is known as N, this one is C and this one is W. So we make a equation which the distance from C to DE equals to C plus W. C to DE is C plus W, which equals to 19. Okay, so the distance from C to AB is C plus N. C to AB is C plus N equals to 40. 40. Okay, whereas for the distance between DE to AB is W plus N. DE to AB, W plus N, which is 41. 41. So 19 is for equation 1, 40 is equation 2, whereas 41 is equation 3. So now we have to subtract equation 3 from equation 2. So W plus N minus C plus N equals to 41 minus 40. So we will get this equation. W minus C equals to 1. So we will know that this is the equation 4. And then we have to add equation 1 and equation 4. So C plus W minus C. So 19 plus 1 equals to 20. So we will get W equals to 10. Since we get the value of W equals to 10, so now we can get the value of C. So C is W minus C equals to 1 from here. So C equals to 10 minus 1, so we will get C equals to 9. Okay, now we know that the value of C is 9. So what is the value of G? The value of G we can get from this equation. So as we can see here, the distance from C to E is the addition of C plus G plus E, C plus G plus E. So from the original table, we can see that the distance from C and E is 20. So 20 equals to C is 9, E is 6. So what is G? So 9 plus G plus 6. Okay, so 20 equals to 15 plus G. So G is equals to 5. So finally, we know that G equals to 5 and C equals to 9.
So hi guys, let us continue to discuss on measuring the value of distance from points. So first, we have known from previous steps the value of C, value of distance D, value of distance E, and value of distance G, which is 9, 4, 6, and 5 respectively. So now we would like to know what is the distance of A, B, and F. So how do we know? How can we know distance of A, B, and F? So first thing first, we have to construct a smaller phylogenetic tree, which involve only the points that we need to calculate the distance, which is point A and point B. Whereas for here, I have decided to combine the sequence into single sequence, which is CDE. So here we can see we can only get what the points, the value of distance that we want, which is A, B, and F. So next, what we're going to do is construct a new distance table. So how do I construct this new distance table? And how do I get the value of CDE distance? So what we have to do is to see the previous ABCDE table.
which is from here, we want to combine the point of C and point DE into one, which is CDE. So what we can do is to get the average of this distance, which is 39 plus 40 divided by 2, which gives rise to 39.5. The same goes to the point of B and DE, which is 41 plus 42 divided by 2, which gives us to 41.5. Okay, so next, what we do is calculate the equation of distance. So equation of distance is we create an equation from point to point. So the first equation is from point A to point B. From point A to point B, we know from point A to point B, we will measure the distance of A plus B. So A plus B is equals to 22 based on the distance table. This is the first equation. For the second equation, we are looking at the point A to point CDE. Point A to point CDE. So the distance involved is A plus F. So A plus F is equals to 39.5. The same goes to B from point B to point CDE, which is B plus F, which is equals to 41.5. So we have three equations. So next we do the algebra expression. Not algorithm, sorry. So first is we subtract the equation 1 to equation 3. So from equation 1 minus equation 3, we will get another fourth equation, which is A minus F is equals to negative 19.5. So the equation number 4 will be utilized for the next algebra expression, which is we add the equation 4 and equation 2, which gives off to the value of A is equals to 10. So now we get the value of A, distance A is equals to 10. So from A equals to 10, we can directly substitute the value of A equals to 10 into the equation 1 because it is very direct. So this is mathematics. So A, we substitute 10, then we will get B is equals to 12. So here, B distance is 12. So the last distance unknown is F. So how do we get distance of F? So here, I would like to see from point to point, which involve the distance of F, which we will have to go through the point F to go to the another point. So here, I would like to give example by using from point A to point C. Why I choose from point A to point C? Because from point A to get to point C, we have to go through the distance of F. So A plus F plus C, we will get to C, point C. Therefore, from A to C, A plus F plus C is equals to 39. From the matrix table of interaction of A and C, we get 39. So we substitute the previous value that we have known, which is A equals to 10 and C equals to 9, we will get F equals to 20. So that's how you calculate the distance value of the phylogenetic tree.